Hello, everyone. Welcome back. Today, we're going to be discussing the fundamental theorem of algebra, and we're going to answer two questions that are related to it. So, first of all, what is the fundamental theorem of algebra? So, it says that if f of x is a polynomial of degree n, where n is greater than 0, so either it's a linear, quadratic, cubic, quartic, etc., something linear or above, basically, then the equation f of x equals 0 has at least one solution in the set of complex numbers. Now, a lot of people will stop me here and say, well, but what about polynomials that only have real solutions? Aren't there some polynomials that only have real solutions? And while that is true, keep in mind that the set of complex numbers includes all the numbers that have complex parts to them, and the field of complex numbers also includes all real numbers. And so all real numbers are also part of the set of complex numbers, but not all numbers in the set of complex numbers are part of real numbers, right? Because real numbers, they encompass rational, irrational, whole numbers, integers, natural numbers, everything really, everything except for numbers that involve I. And then complex numbers includes all of that, all the real number stuff, plus anything that has an imaginary component that has I in it, right? So for example, 3 is a real number, which makes it also part of the complex number set because all real numbers are complex numbers. Whereas 3i, for example, well, now that we have I, this is only a complex number. It's not also a real number. And so hopefully that kind of clears that up, that because complex numbers encompass all complex numbers and all real numbers, that's what they're meaning by that. Let's move to the corollary here. This is very useful as well. It says that if f of x is a polynomial of degree n, where n is greater than 0, then the equation has exactly n solutions, provided that each repeated solution counts once per repeat. So let's talk about what that means in the context of quadratics. So what this is saying is that all quadratics, because they're degree 2, that all of them must have exactly 2 solutions. And you might be thinking, but didn't we learn in Algebra 1 that there's either 0 solutions or 1 or 2? And yes, that is true, right? If there are 2 solutions, in the way we previously would have stated it, that would mean there's 2 real solutions. If there are no solutions or no real solutions, that just means that there really are 2 solutions, but they're complex numbers, they're complex solutions, because we end up with a negative discriminant. And in the event that we have one real solution, that does mean that that is the one and only solution. However, it does say in this definition, provided that each repeated solution counts once per repeat. And so since that's a solution that is repeated twice, right? Since if we have that, we have something like, x minus 1 squared, for example, that's a repeated solution. So since it's repeated twice, we count it as 2, even though technically it is only one solution, right? And so that's what it means in the context of quadratics. So using this corollary, can we answer the following questions? The first one says, how many solutions does this quadratic have? And my answer is 4, because as you can see, our leading term here is x to the power 4, meaning that this is a degree 4 polynomial, so there are 4 solutions. Now keep in mind, there might not be 4 real solutions. Like if you graph this on a graphing calculator, it might not actually hit the x-axis 4 times. It might hit less than 4, and that could be for one of 2 reasons, or possibly both reasons in some cases. That could be because some of those 4 solutions are complex solutions, or it could be if some of those solutions are repeated solutions, and so they're counting as more than one, even though they are technically only one solution, right? So those are the possible reasons why if we were to graph this, we wouldn't actually necessarily see all 4 solutions in the graph. Okay, let's move on to this next one. How many solutions does this one have? Well, this one has 3 solutions, and again, some of those solutions might be complex and or repeated solutions. But if we're including repeated solutions as, once per repeat, and we're including complex solutions as solutions, this would have 3 solutions because it is a degree 3 polynomial. As always, feel free to leave any questions you might have in the comments, and we will see you for the next one.